Z transforms. So here we are discussing about a difference equation. So here let y equal to f of x, where x is x0, x1, x2, xn plus 1. Similarly, y corresponding value of y is y0, y1, y2 up to yn plus 1. And here first difference while finding, we are representing this as delta y0, where delta y0 is nothing but y1 minus y0. So similarly, delta y1 we can write it as y2 minus y1. Then here delta yn we can write it as yn plus 1 minus yn. And here to find out the second difference, we are finding the difference between these two values, that is delta y1 minus delta y0 is nothing but delta square y0. So here delta y1 is nothing but y2 minus y1 minus of delta y0 is nothing but y1 minus y0. If we simplify this one, we get y2 minus 2 times y1 plus y0. So similarly, del square yn we can write it as a delta of delta yn, where delta yn can be written as yn plus 2 minus yn plus 1 minus of yn plus 1 minus yn, we are getting yn plus 2 minus 2 times yn plus 1 plus yn of the form. The equation of the form yn plus 2 minus yn equal to 0, or yn plus 2 minus 2 times yn plus 1 plus yn equal to 0, or any other form of the is the relation between differences of dependent variable. Differences of dependent variable is nothing but y. Transform of un, where un is function of n, can be written as summation n is 0 to infinity un into z power minus n. So here un is 0 if n is less than 0. So here n is nothing but 0, 1, 2, 3, so on. So here we can write the reverse process of this one, z transform of un, we can write it as u bar of z. It is nothing but answer written in the form of z. So and un can be written as inverse z transform of u bar of z. Property z transform of n power k equal to minus z into differentiation of z transform of n power k minus 1 with respect to z, where k is positive integer. So to prove this one, we consider the right hand side. So here RHS is nothing but minus z into d by dz of z transform of n power k minus 1. So by definition of z transform, we can write it this as summation n power k minus 1 into z power minus n. So summation n is equal to 0 to infinity n power k minus 1 into z power minus n. So here we are differentiating with respect to z. So we get z into summation n is 0 to infinity n power k minus 1 is constant, and z differentiation is minus n into z power minus n minus 1. So now if we multiply this one, we can write it as summation n is 0 to infinity. So here n is multiplied, we get n power k, and here if we multiply this minus z, we get z power minus n. So this is nothing but definition of z transform of n power k. So here z transform of un is nothing but summation n is 0 to infinity un into z power minus n. So here some standard z transform of some standard function. So here z transform of k power n. This one we cannot substitute the answer, find out the answer directly, so we use the definition. So by using the definition we can write it as n is 0 to infinity k power n into z power minus n. So here z power minus n we can write it as k power n dividing by z power n. So summation n is 0 to infinity, and here we substitute n equal to 0. First this one also can be simplified further. We can write it as summation n is 0 to infinity k dividing by z power n. So by substituting 0 we get k by z power 0 is 1. By substituting 1 we get k dividing by z. By 2 we get k by z whole square plus k by z whole power 3 plus so on. So this one we can write it as 1 minus k dividing by z. We take the LCM, and this one is power minus 1 formula. We can write it as 1 dividing by 1 minus k dividing by z. 1 dividing by z minus k dividing by z equal to z dividing by z minus k. So this is the very important standard formula. Z transform of k power n can be written as z dividing by z minus k. So here k is 1. Then z transform of 1 power n is nothing but 1. We can write it as z by z minus 1. So similarly here we can write it as z transform of any constant a or b. We can write it this as z transform of 1 into a. So we get a into z dividing by z minus 1. Now we find out the second standard function z transform of n power k, where k is 1. Okay, n power k we can write it as minus z into d by dz of z transform of n power k minus 1. Here k is 1, then we can write it as z transform of n equal to minus z into d by dz of z transform of 1. If we substitute we get n power, here n power 1 minus 1 we get n power 0. N power 0 is nothing but 1. So z transform of 1. So here minus z. So first we must know the formula of z transform of 1. So z transform of 1 is nothing but z dividing by z minus 1. So we differentiate this one. So if we differentiate this one, we get minus z minus 1 whole square into z minus 1 into z minus 1 minus differentiation of z is 1 minus z into z minus 1 is 1. So here we can cancel z. So that minus into minus we can write it as z dividing by z minus 1 whole square. So this is nothing but z transform of n. So similarly, we can find out the same way. Z transform of n square is nothing but minus z into d by dz of z transform of n. So we know the formula of this one, minus z into differentiation with respect to z of z dividing by z minus 1 whole square. So if we simplify this one, we get the answer z square plus z square plus z dividing by z minus 1 whole power 3. So similarly, z transform of n power 3, we can write it as z cube plus 4z square plus z dividing by z minus 1 whole power 4. So while solving the problem, we must remember these things. So here we discuss some of the basic problems using these formulas. So find the z transform of n plus 2 whole power 3. So here n plus 2 whole power 3 is there. First we must apply the formula for a plus b whole square. Sorry, power 3, n plus 2 whole power 3. We can write it as n cube plus 3 into 2 6 n square plus 12 n plus 8. So now we have the formula for this one, n cube. N cube is nothing but z cube plus 4z square plus z dividing by z minus 1 whole power 4 plus 6 times n square is z square plus z dividing by z minus 1 whole power 3 plus 12 times z is z by z minus 1 whole square plus 8 is nothing but 8 into 1, z transform of 1 is z dividing by z minus 1. Transform of e power a n. So this one we can modify and we can write it as e power a whole power n. So here let we consider that let e power a is nothing but k, then this become k power n. So k power n is z by z minus k. Here k is e power a, so z transform of e power a n we can write it as z dividing by z minus e power a. So similarly, z transform of 2 power n, it is nothing but the form of k power n formula. So z dividing by z minus, instead of k we have 2, so 2 power n is nothing but z by z minus 2. Suppose if we have the problem based on 1 dividing by 3 power n, so this one also we can write it as z by z minus k is 1 by 3. Then we take the LCM, z dividing by 3z minus 1 by 3 equal to 3z dividing by 3z minus 1. The same problem we can solve by without using this k power n formula. We can use the definition of z transform. We can solve similar to z transform of 1.